Now that you've got a chance to get a feeling for the case study example of Java threads, let's start taking a look at some of the things we kind of glossed over a little bit as we were going through the example. And we'll start by talking about ways of giving code to a Java thread. And as you'll see, there's a couple different ways to do this. So, sort of obvious, I guess, but a thread has to be given code or must be given code in order to do anything useful. In particular, do not ever write code like this. Even though it's perfectly plausible to do so, it will do nothing. I have no actually any idea why it's even a valid option in Java. But you can make a new thread object that has nothing given to the constructor, and you can start it. But it won't do anything. It's basically lobotomized. It has no brains. It can't do anything. It's like a zombie. So there are different ways to give code to Java threads, and I'm going to walk through them with you. The first way we're going to look at, which is at least at face value the simplest, is just to extend the Java thread class. So here you can see we have the Java thread class. We use the extends keyword, which basically means inherits. And we say GCD thread extends thread. And that gives us this run hook method where the actual code will go. So you have to override the run hook method to provide it stuff to do. And we'll see that's the case for anything here. Sometimes it's more explicit, however, that you're overriding run. Once we have ourselves the GCD thread, then we can make a new instance of that thing. And in this particular case, the GCD thread knows what to do with run, so we don't have to give it a parameter because it knows what to do. And the run hook method will get called, and when we start the thread object, it will do its thing. It'll call run. You can also write code that does an anonymous thread object. So here we say new GCD thread dot start, and that will actually start and run that thread. Now, why would you ever do this versus that? Well, the main reason for doing this is if there's some reason you want to synchronize or somehow interact or interrupt the thread object you created. If you don't care about that, you could just make an anonymous thread object. But if you want to be able to interact or control or manage the thread after it starts, then you want to keep track of its objects so you can do other things to it. The second primary way of giving code to a thread is by implementing the Runnable interface. So here's Runnable. You can see Runnable is what's called essentially an abstract interface. It's basically, or it's sometimes called a functional interface. It only has a single abstract method in it, and we're going to have to implement Runnable and override run in order to be able to get it to do something useful. There are two primary ways of managing runnables. One is to create an instance of a named class. As you can see here, GCD Runnable implements Runnable and fill in the run hook method. Then you can say new GCD Runnable. That's one way to do it. And after we do that, we can then pass the Runnable object to the thread constructor and start it. There's another way of doing this, by the way. I'm getting a little bit ahead of ourselves because this isn't quite ready for prime time yet. But if you're running in modern Java, so modern, maybe I should call it future Java to differentiate from what we have right now. This is how you create a Java thread with Project Loom. You say thread.ofplatform.start GCD Runnable. So that's the way you do that. Another way to do this is to make an anonymous runnable and give that to a thread as the thread's constructor. So here we have an anonymous runnable with a run hook method. And as you can see, in this case, we have an anonymous thread also. So we can create and start the thread using an anonymous inner class. This funky syntax here is called an anonymous inner class. This approach is used quite frequently in older Java code, and it's used quite frequently in older Android code, but it is unfortunately tedious to program because there's a lot of syntax. Therefore, in modern Java, which is what's called Java 8 and beyond, you can use something called a lambda expression. And a lambda expression is an unnamed block of code with optional parameters that can be passed around and executed later. And we'll talk a bit more about that because that's a very important thing to understand. This class isn't really a class on modern Java per se, but it wouldn't hurt to know enough of it that you can write modern code. So this This works very nicely if you have like a one-shot thing that's really short you're doing here. It becomes unwieldy, however, if this code here is very long, complex, or most importantly, needs to be reused multiple times, because then you end up repeating yourself. And you don't want to repeat yourself. DRY, don't repeat yourself. Dry, the dry principle. Therefore, if you find yourself with lots of code or code that needs to be repeated, you can stash that code into a runnable using the Lambda syntax I show you here. And then you can just pass that runnable into a thread. So that's an overview of various ways that you can give code to a Java thread.